Hello, this is Dr. Chimbitsky and welcome to my environmental science screencast. Today we are going to discuss the scientific reasoning. Hello, today we are going to talk about principles of science and systems. So remember that last time we discussed environmental science and we tried to separate the idea of environmental science into the idea of the environment and the idea of science. We are familiar with definition of the environment and we had very in-depth discussion boards which are related to the environment. And so now is the term of science. So we have to decipher the meaning of science. And this is what we are going to do today. As you look at this illustration, which actually opens the second chapter in your textbook, you can observe university students that engage in some type of a plant experiment. And actually, if you are really interested what they are doing, you are welcome to read the case study that opens chapter number 2. Alright, so very well. So what is the question here? So the question is, what is science? So let's try to understand this. So here is a formal definition of science. So science is a process of producing knowledge methodically and logically, right? And when we think about the definition of science, we would like to know what are the main attributes of science and what actually can be defined as producing knowledge in a methodical and logical way. So to be able to understand this, we have to look at two things, which are the two main attributes of science. So the attribute number 1 is the scientific method, and the attribute number 2 is the scientific reasoning. There are other ingredients that contribute to our understanding of science, but let's start with these two, the scientific method and the scientific reasoning. I also encourage you to read your textbook so you can understand the idea of science a little bit better. And again, here is the definition of science, a process for producing knowledge methodically and logically. We have already discussed this. And if we actually look at the origin of the word science, again, it's not an English word. So scire derives from the Latin, which means to know, right? And that's why right here we can again come to the same definition of science as a process of producing knowledge, but not just producing knowledge, but producing knowledge methodically and logically. So very well, now let's scroll a little bit down along our ebook, and as we keep moving along, we will see here the steps of the scientific method, which are shown right here in this diagram. And I would like to skip over a little bit because I would like to spend more time on the scientific method a little bit later. And right now I would like to focus on the scientific reasoning. So let's take a look here. There are two types of the scientific reasoning, which are called the deductive reasoning and the inductive reasoning, and both of them can be quite useful in science. So the deductive reasoning actually, this philosophical term is older than the term of inductive reasoning, and deductive reasoning was introduced for the first time by Aristotle. And then inductive reasoning idea was developed a little bit later by Sir Francis Bacon. So let's take a look and try to understand the idea behind these two types of scientific reasoning. So very frequently we are looking at the environment, and we are able to deduce some conclusions from general laws if we know that this general law is true. For example, Aristotle says all men are mortal, right? This is very general. So if we believe that all men are mortal, and this is true, we can kind of take it as general knowledge, and we can also derive more specific conclusion. So Aristotle says all men are mortal, right? Now, Socrates is a man, and therefore, because all men are mortal and Socrates is a man, Socrates is also mortal. So what we have here, we deduce conclusion based on the general law that all men are mortal, and obviously this will only work if the general law is true. All right, so here is another example from your textbook, which is a little bit more contemporary example. So if we know that massive objects attract each other because of law of gravity, and then it follows that an apple will fall to the ground when it's released from a tree, right? So this is an example of the logical reasoning, which is called deductive reasoning, right? So imagine you have some type of a fruit in your hands, you have an apple, and if you're going to release the apple, you're not holding it anymore, what's going to happen with the apple? That apple is going to fall down and hit the ground, right? So do we really have to test it, or we kind of already know what is going to happen to the apple? What about a different object? If it's not an apple, if it's a book, if you're holding a textbook in your hands and you're going to just let it go, you're not holding it anymore, will it still hit the ground? And the answer is yes. We don't have to try to prove it. We can predict what's going to happen with a book, or with an apple, or with a pen, or any other type of object, because we have a general idea of the law of gravity. So based on the general law or general idea, which is assumed to be true, we can make specific predictions about the behavior of different objects. In this particular case, an apple, a book, a pen. So we are following the deductive reasoning. Alrighty, so let's think about it and let's try to summarize what we know about the deductive reasoning. So deductive reasoning is logical reasoning when our flow of logic goes from general to specific, right? Our general knowledge is that all objects are subject to the law of gravity, and our specific prediction that an object, such as an apple, is going to hit the floor or the ground if we are not holding the apple in our hands anymore. So once again, the important point here, when we apply the deductive reasoning, our logic moves from general to specific. Very well, so let's think about it. So, but what if the general law isn't available and we don't really have this luxury to rely on some type of general law. All right, so imagine that we have no idea about gravity. Is it possible? Think about a young child that just learns about the world and interacts with different objects. A young child might have not gained the knowledge of gravity yet. And if you have children, or somebody else in your family have children, you know how investigative children can be. And so a young child will pick up a teddy bear or another toy and will drop it and observe that the toy is going to fall and hit the floor. So next time it's going to be a different object. It might be not the teddy bear, but a different type of a toy, like a doll. And the child again picks up the doll, drops it, and observes what happens to the doll. And so hopefully parents are taking care of the objects which are available in the close proximity of their children, and there is no fragile or dangerous object the child would experiment with. But after these interactions with a doll, a teddy bear, and maybe a few other objects, the child will come to a conclusion of gravity. And at this point, they might not know the word of gravity, and they will not call it gravity or the law of gravity, but they will have general understanding how gravity works. And in this particular case, the child interacted with a specific toy, such as a teddy bear, and then with a doll, and then with several other toys or objects. And based on this specific observation, the child formulates a general idea about gravity. So in this particular case, when the general idea is not initially available, we are talking about the inductive reasoning. So let's try to summarize the meaning of the inductive reasoning. So inductive reasoning is also logical reasoning, but now the flow of logic goes from many specific observations to produce a general rule. So in this example that we just described, the child interacts with many specific toys and objects to formulate their idea of gravity, which is more general. And now if we give the child a different toy, they will know what's going to happen if they drop it. So the flow of logic is opposite to the deductive reasoning. Once again, deductive reasoning is a logical reasoning from general to specific, and the inductive reasoning is going to be the logic in the opposite direction from many specific observations to produce a general rule. Very well, so let's take a look at the textbook once again. And so our textbook tells us that often we do not have general laws to guide our decisions. So for example, we can observe that birds appear and disappear as year goes by, right? So we know that spring is coming, summer is coming, and as there are birds who are returning to their habitat after the winter season. And maybe sometime in the fall, they will disappear from our backyard, right? And so if we are going to repeat this type of observations about the behavior of the bird, we can derive a general conclusion. So through many repeated observations in different places, we can infer that birds move from place to place. We can develop a general rule that birds migrate seasonally, right? So assuming we didn't have this knowledge before, by repeating observation this year and the next year, and the year after that, so many specific years, let's see, 2000, 2001, 2003, etc. Eventually we can come to a conclusion that there is a seasonal migration of birds. And so what type of reasoning is this? So because we are moving from specific observations, so we are moving from many specific observations to produce a general knowledge, about bird migration, we are using the inductive reasoning. Obviously, in this example with bird migration, we didn't have the general knowledge to begin with. That's why we had to do specific observations. But if this knowledge is available, for example, you took a class in the middle school and your teacher told you about general seasonal birds migration, right? So you might not necessarily do these specific observations yourself, but because you gain the general knowledge by taking a course or listening to the instructor or the teacher, you can actually predict that this year in the spring certain type of bird species will appear in your backyard. So if the general knowledge is available, then we can use the deductive reasoning. So in science, both type of reasoning are very useful, and sometimes general knowledge is available, sometimes the general knowledge is not available, and depending on the circumstances, we will use either the deductive reasoning or the inductive reasoning. Alright, so here we have some pictures of beautiful cats. And I have pictures of Egyptian Mau on the left-hand side and Singapura on the right-hand side. And I have the pictures of beautiful cats for a reason, because I would like to apply the scientific logical reasoning here. So let's try to do this, and I am gonna open the logical reasoning with a general statement. So my general statement, and actually let me type it for you, my general statement would be that all cats have a tail. So this is general, right? General statement. General, all cats have a tail. And how do I know that this is general? Because I said that all cats have a tail, right? So this is in general. It doesn't apply to any kind of a particular type of cat, and that's why it's general. Now, let's take a look at a specific cat. So on the right-hand side, I have the cat, and the name of this cat, it's a Singapura cat. The name of the cat is Singuil Emerald. All right, so I'm gonna say that Singuil Emerald, and this is a double name, so that's why it's capitalized, is a cat, right? Do you have any doubt that this is a cat? It is a cat. So I'm gonna put a period here. I'm gonna put a period here. And can I conclude something based on my general knowledge that all cats have a tail? I can say, so because Singuil Emerald is a cat, and this is a female, you see F stands for F, Singuil Emerald is a cat, so because of that I can conclude it will have a tail. So Singuil Emerald is a cat, and therefore she has a tail. And so just imagine that I haven't seen the picture of the cat, and I just used logical reasoning, right? And if you look at the picture, it really is true. She has a tail. Right? So here we go. Here is our reasoning we are moving from number 1, which is a general knowledge about cats, and we are arriving at a very specific conclusion about this particular cat, which is Singuil Emerald. Not this cat and not any other cat. We are concluding that because Singuil Emerald is a cat, therefore she has a tail. This is an example of deductive reasoning. Alrighty, and so now let's practice the deductive reasoning one more time. And in this example, I actually would like you to be familiar with this absolutely magnificent cat. And I'm actually proud that I have met this cat at the cat show. This is the best cat in championship in the Mid-Atlantic region. It's absolutely beautiful snow white cat that is owned by somebody I know fairly well, and I really admire this cat. So let's try to use the deductive reasoning. And the name of the cat here is Mystic Springs Arctic Storm, because the cat is so snow white. That's why the name is Arctic Storm. So let's start from deductive reasoning logic. So we have to have a general starting point. So all cats have a tail, so we already know that. And now we also know, because you see it's a best cat in championship of 2019-2020 show season in North Atlantic region. So it's a cat. And so Mystic Springs Arctic Storm is a cat. And what we conclude here, based on our general knowledge, because Mystic Springs Arctic Storm is a cat, he has a tail. So this is your typical deductive reasoning. Now, guess what? So my conclusion was, because Mystic Spring Arctic Storm is a cat, he has a tail, and this is actually not true. This is wrong. This is wrong. Absolutely wrong. So I'm going to just cross it over because this is false. So this cat actually has no tail. Okay, and so now let me show you the cat. So we are kind of all on the same page. Absolutely beautiful cat. So let's just pause for a second and admire this breeding work masterpiece. And you know what? This is normal for this type of cats to have no tail, because the breed is Manx. And Manx is the breed of a tailless cats. This is an interesting breed that actually derives from the Isle of Man, which is in Europe. And, cats use their tail for balancing. And because this cat breed has no tail, they have to compensate for the absence of the tail. And they have to have very well developed back legs to be able to balance better. And they're very nice and very, friendly cats with no tail. So what does it tell us? That we use deductive reasoning in science very often. However, we can't always rely on deductive reasoning. The deductive reasoning will only help us if our initial idea, our general knowledge, is correct. And obviously now, after we look at this beautiful cat, we know that not all cats have tail, and so we can't really use logical reasoning in this case because our general premise isn't correct. Okay, so I hope you grasp the difference between the inductive and the deductive reasoning. And now I would like to test your understanding of the difference between these two types of scientific reasoning. So I'm going to describe a scenario, and you are going to listen very carefully to the description. And at the end, I would like to know your opinion. What kind of reasoning we are talking about? Is it the deductive reasoning or the inductive reasoning? And so remember, the deductive reasoning constructs the logic from general to specific, and the inductive reasoning constructs the logic from specific to general. So these are the main difference. These are the main differences here. Okay, so imagine that, today is, let's see, Tuesday, right? And it's a Tuesday night, and you are at home in your bedroom, and maybe you are doing your homework because, your environmental science instructor assigns a lot of work in your online course. Or maybe you're relaxing and you are listening to the music, or maybe you're playing with your cat, or with your dog, or with your ferret, etc., etc. Maybe you're watching TV. Who knows, right? But the thing is, your bedroom windows are facing the backyard. You cannot see the front of the house. And you also know that your mother comes from work, and your mother is an essential worker. So maybe she's a nurse, or some type of another essential service, individual. And you know that she goes to work, and so she's away all day, and she comes home at around 6 p.m. So generally speaking, usually. Well, it's not always 6 p.m. Sometimes she has to maybe stop at the grocery store. Sometimes she has something else to do before she actually comes home, but usually it's around 6. So now you're in your bedroom doing your homework or listening to the music, and let's see, it's 5:50 p.m., almost 6. So you can hear that a car pulls in your driveway. You cannot see outside because your windows are facing the backyard. However, you say to yourself, well, this must be my mom back from work. Did you use logical reasoning? Yes, you did. What kind of reasoning? So I'm gonna pause for a second, and I would like you to think about my example and pick either the deductive or the inductive reasoning. And here is a definition of these two types of reasoning for you one more time to make it easier. So in my example, did I use the deductive reasoning, or did you use the deductive reasoning because we are imagining it's your house? Or did you use the inductive reasoning? Okay, so what I want you to do, I would like you to take a piece of paper and honestly write your answer down. Deductive reasoning or inductive reasoning. All right? So I'm going to wait just for a little bit so you have time to grab your paper and pencil and write it down. Okay, ready? So I trust that you did, and I'm going to tell you the correct answer, and you will compare. The correct answer would be the deductive reasoning. Okay, logical reasoning from general to specific. Why? Because remember how I said in the beginning, usually, my mother comes home at around 6 p.m. Right? So this is general. This is what generally happens. Now, I'm looking at a specific day, such as, for example, Tuesday, May 19th, 2020. And this is a specific occurrence. Somebody pulls in the driveway. I cannot see who is outside, but I use the deductive reasoning based on my general knowledge that normally, my mom comes home at around 6. I can say, well, this could be my mom. Now, can I be wrong? How I can find out? Well, I can run downstairs, open the door, or I can wait until my mom comes into the house, because it might be her or might be not. So it may be somebody else. It may be your friend visiting you. It may be a relative. It may be your dad, or it can be some person who is lost in your neighborhood and just using your driveway to turn around. That can happen as well. So you have to go out of your bedroom and see who is there to find out if your reasoning is correct or not. In science, however, we would have to do an experiment. All right, good job. So ready for another example? So once again, I am going to describe a scenario, and you will pay attention, and using the details of my scenario, you will try to decide if I'm going to use the deductive reasoning or the inductive reasoning. So once again, your mother generally comes at home at 6 o'clock. However, something happened, and let's see, maybe your mom got promoted, and she was just a regular nurse, and now she is a nurse supervisor. However, her company transferred her to a different hospital in a different location. It's a larger hospital, and you live in New Jersey, but now the new job is located in King of Prussia, Pennsylvania. Right? And obviously, it's further away. It will probably take longer to get home. And it might be not really applicable right now, but usually there is a lot of traffic because of the shopping mall in King of Prussia, Pennsylvania. So you might not necessarily be sure that your mom will get home by 6. You're assuming that it can be actually later. So what happens, let's see, today is Tuesday, the 19th of May, and you're at home doing your homework, and your mom comes home at 6:45 p.m. So the next day is Wednesday, and again, you're at home, you're doing your homework, and all the assignments that your professor prescribed to be done for the Living in the Environment class. And your mom comes home at around 7:10 p.m. And now the next day is Thursday, and your mom comes home at maybe 7:05 p.m. And on Friday, she comes home at 6:55 p.m. And she also works Saturday and Sunday. And on Saturday, she came home at, 7:20 p.m. And on Sunday, she came home at, 6:45 p.m. And so after observing what was happening for a week, you observe what was going to happen on Tuesday, on Wednesday, Thursday, Friday, Saturday, and Sunday. And after about a week, you say to yourself, well, with this new job, my mom will probably be able to make it home at around 7 p.m. only. So, did you use scientific reasoning? I'm sure you did. So what kind of reasoning? The deductive reasoning or the inductive reasoning? Here's definition of deductive and inductive reasoning for you on the screen one more time. So again, I'm going to pause for a little bit. I want you to think what type of reasoning was used in my second example. And again, I would like you to use a piece of paper and pencil and write your answer down. All right, I'm going to stop and you will think and write down your answer. All right, so ready? So I trust that you truly wrote your answer down, and I will reveal the correct answer. This was the inductive reasoning. And why it was the inductive reasoning? Because the general knowledge about the time of arrival wasn't available. It's a new job, a new location. And what you had to do, you had to make several specific observations. You observed the time of arrival on Tuesday, on Wednesday, on Thursday, on Friday, on Saturday, on Sunday. So you had 6 separate observations. And only after you did 6 separate observations, you were able to produce a general rule. Well, with this new job and promotion, my mom will get home at around 7 p.m. So you clearly followed the inductive reasoning. Very well. So I hope that now you have a good grasp of the 2 types of the scientific reasoning, the deductive and the inductive reasoning, and you know the differences, and you can apply these 2 types of scientific reasoning. Very frequently we are using logical reasoning in everyday life. We just don't know it is called deductive and inductive reasoning. We will also have a follow-up lab exercise when I will ask you to use the logical reasoning to solve a puzzle. And this is going to be an important assignment that will allow you to gain points both for watching this video and for the lab assignment by itself. So if you have any questions, you know how to get in touch with me, and I will see you soon.